Hello, everyone, and welcome to my session today. We will talk about supply chain attack and how to prevent it on the CI/CD process. We'll talk about different types of supply chain attacks. But before we are going to dive deeper to the technical parts, let me just introduce myself. My name is Vitaly Davidoff. I'm an AppSec lead at JFrog. Used to be developer for many years, moved to security field about 7 years, for 7-8 years, and now I'm responsible for the all cross products at the JFrog platform. So what is going to be our agenda today? As I said, we will talk about supply chain security problems. So what type of attacks we have. We will see how malicious packages might be infected by attackers or by malicious users, how to detect those packages, infected packages, and how can we use best practices to avoid supply chain attacks. And we also have time for questions at the end. So let's get started. And first of all, supply chain. So what is the idea behind supply chain? First of all, as you know, we are using open software packages everywhere. It's going to be the most part of our software or of our applications. As you can see here, so actually, once I build my software, I have more than 75, maybe 80% of the runtime code built from the third-party open source packages and not from my first code. And that's something that good. Okay, so it's actually a very good trend. You can see here it's not so up-to-date graph, but you can see the trend that we are using a lot of open source new packages every year on the different programming languages, different build managers, like on the Java, Maven, and NPM, etc., on different languages. Also, the trend of the download for open source libraries, as you can see here, again, is from 2019, but the trend is the same at this year. It is going to be the same for the next year because we are downloading open source, we are using open source packages, component, like as you can see, the examples of the NPM and Java and the billions and billions of downloads. As you can see, it started around 2015-16 because at that time we introduced the CI/CD process. And once we have automation for our builds, for our continuous integration, we suddenly started to download software open source components in the bunches and the millions. So why it's good actually? First of all, it's a very simple way to do something from the programmer point of view, from the developers. Okay, just the example, you can see very short 10 lines source code, and just to open listener for request response, and that's it. Okay, on the specific port. But just think about it that I need actually to program to code all the functionality for open ports, for touch and actually deal these requests and responses on the low level. But I don't need. What I need from my side as a developer, I just need to include, okay, or part of the required Express package. Express is a very popular open source package, and that's it. Okay, so I can 10 lines of code, and I have HTTP listener for requests and response on the specific port. So that's very clear. It's very short. It take me can take me 5 minutes, okay, 10 minutes to do so, just to understand what is Express and review documentation and see what options I have, and that's it. Okay, it's very clear. It's a short code. Great. Okay, so I don't need create network manipulation code again on different applications, so I can just use Express and that's it. So XRAY is the best practice. Okay, but what we can see on the runtime, bottom line, when we're running our code, when we have our software released, we will see the huge number of code lines. Okay, so you can see here. So actually, why? Because Express itself uses third-party components and those components in other components. So it looks like that. So once we include or bring our Express open source as my first dependency, Express will bring other dependencies, and those dependencies are other dependencies, and so on. So they actually, as you can see on the runtime, I will have a very big, the huge number of code on my productions. Okay, so first of all, just think about that. I don't need to code all of it. Okay, so I have it for free, and I just need to use one line of code in order to bring all of these graph in my code. So that's the idea behind the open source components and the usage of open source components. So the supply chain is actually how can I bring Express, for example, to my code, and then how can I supply my software to someone to my customers. Okay, and this process we call it supply chain. Okay, so as I said, some points regarding supply chain in general. Okay, so as I said, modern software development and application integrate third-party code. It's very clean. It's a good practice. So my delivery, some time to market, it's very short because I'm using open source third-party packages. I don't need to pay. I just need to verify the license so that I can actually produce or include those third-party packages to be part of my applications if I need. But we have some points I just wanted to emphasize. So applications trust third parties to supply secure code. Okay, so this point is might provide me the different feelings because applications trust the third party to supply secure code is something that I cannot agree. It's a true for our days, but just think about it. Everyone can add any type of code, anything, okay, to npm, for example, registry. Okay, so we trust those contributors, but how can we sure that contributor will be not will be the malicious one, okay, or don't want to open some backdoors or do something wrong. Okay, so it's very problematic point. Trust third-party supply secure code because it might contain vulnerabilities or it might also contain malicious code. So, and why attackers want to do so, or malicious user attackers? Okay, so I will use attackers. So first of all, it's a high spread attack. Why? Because I don't need to deal this application and all the layers of defense for specific application, specific environment. What I need to do, I need somehow, okay, we will talk about it. We need somehow to infect our supply chain process and provide malicious package. And once someone or users, developers, DevOps engineers will search and bring my malicious package, this package will be in a lot of on the lot of customers. Okay, and as you can maybe you remember, maybe you remember the SolarWinds attack where we actually one malicious component lead to a lot of breaches in the thousands of customers just because one package. So I have worked once as an attacker to create my malicious package, and then I will try to spread it to as much as possible. Low effort, yes, again, so I don't need to breach all the security controls on the systems and take control other services, etc. Okay, I'm just sitting and wait until my code will be on the runtime. And once it's on runtime, for example, I will receive notification, or I will receive the request for open reverse proxy, and that's it. So I just need to wait, actually. Low technical skills required is it's correct, because I actually need only to be to have the coding skills and understand what can I do. So what is options, how to leak data or how to work with files. But I don't need to understand how to bypass network protections, how to bypass browser protection, web server protection, API protection. So I don't need it, because once my code is already inside, so I don't need to breach all the shields. Yeah. And the trust in the relationship between parties that can be abused. So it's, as I said, so we trust those contributors, and that's how I actually can go to the code. Okay, go to the packages. So, for example, I can do something in order to upload my new malicious version to existing security project. Okay, so, and once we have trust between parties, customers or users, developers, engineers, or DevOps engineers will use it. Just the short overview of the from the Zero Dune. It's how customers or how companies pay for different breaches related to the supply chain attack, like it might be a remote code execution and by some other attacks on the NPM, on the some others. Just as you can see, it's a huge number. Just to be sure that pipeline code or pipeline attack is not there, I will pay a lot of money, okay, just to close it. Okay, so damage. Okay, so what damage? I think it might be everything. Okay, from stealing the access key and just completely destroy database, and open backdoors like reverse shells, so attacker can access my access victims machine or clusters. It also might be something less damaged, but it's still the problem where the attacker will use resources, victim resources, for a crypto miner. So, as I said, it might be different options for different attacks, and all of them part of the supply chain problems, supply chain attacks. So now let's talk about threats, or what kind of the attacks we have on our supply chain process. I will divide it by the two parts. One is the known and one unknown parts. So known parts is then we're using packages with known vulnerabilities. What does it mean? That research teams from different security tools, software composition analysis tools, they will investigate problems or vulnerabilities on the existing packages, and they will add knowledge of this vulnerability to the public vulnerability database. This issue will receive something like CVID, so the common vulnerability enumeration ID. Here's just an example. how it looks like. So it's CV ID is the year, the number of the issue, package name or product name, versions, description of the product, and the severity, security severity. So for example, if we are talking about problem which can lead to remote code execution or account takeover or some other huge damage on the system, it will be high or critical severity. But in any case, I have CV number or CV ID, and I have all the description, all the parameters. So it's something known, and once I can scan my third-party component and see the list of CVEs, so what I'm doing, I'm scanning. We will talk about the tools or vendors. We can use a software composition analysis tool. We will scan our package, and we will see the list of the vulnerabilities. So we'll request NVD database and receive CVEs list for this specific package for this specific version, and then I can take an action like, okay, I can stop my build, or I can think about maybe to change package version, etc. Okay, so this is something known. Okay, I call it CV. But we also have the second part. The second part is the malicious component without CV. So it's something the 0 days. We call it 0 days, so it's unknown. We don't have CV ID on the database, and maybe it just introduced the malicious code as part of the existing package without any CVs. It's something new, and we will talk about it. And just the real examples. I think I don't want to spend a lot of time here. As you're aware of the Spring Shell, it was the remote code execution on very popular Java framework Spring. Here's the CV. So it was researched and caught the CV. It was the critical, I think, and I remember well. So it's again. So once I'm using Spring and vulnerable version of the Spring. Once I'm scanning my Spring packages, this software composition analysis tool, I will receive this CV from the database and can say, okay, so maybe I'm wrong. I need to change the Spring version to the not affected, etc. SolarWinds, again, as we discussed, so the SolarWinds, it was the huge impact once the attacker used to publish malicious package and was infected a lot of customers. It was the very big noise from this issue. You can read it about it, and actually something unknown or malicious component introduced on the NPM on Azure. Again, this is a large scale. It's going to be always the large scale because, as I said, I need only upload malicious code, malicious package once, and all the users will touch it again, will take it. Okay, so let's talk about non-malicious packages. Once we have CV IDs, once we have database with known CVs, we need to scan our software or third-party packages in order to see if we have those CVs as part of this version we are using. So where we are scanning, it might be part of the ID integration, for example, for IntelliJ, for Microsoft tools, etc. So I'm scanning it during my development phase, and I see all the CVs I have. I just bring from the remote repository and see if we have vulnerabilities. So I can change it immediately. It's a best way to catch known CVs in the third-party code during the development process. We also call it pre-commit scan. The next is the build phase. In most cases, we want to scan our code and our artifacts we are using or we created as part of the build before we merge it to master. And I would say that is the first gate, because in this point, I can stop my CI process. It say, okay, so I have vulnerabilities. I have critical CV on the Apache common package, for example. It's very popular for the Java developers. And once I have this critical issue, I want to stop my process and fix it before it's going to the master. So it's the first gate. It's the first and very, very important gate. And the last one is the deploy phase. At least we need to scan it before the deployment part, because we might introduce more packages as the final release or final build. And again, we're going to scan it with software composition analysis tools and see if we have new CVs or new introduced CVs for our packages, for our containers. And again, we can take an action here and say, okay, so we will stop this process at this moment because we have critical high vulnerability CVs. Okay, it's based on the company policies. So if you have policy which restrict access or restrict usage of components with critical and high issues on the production, you can just stop this process in this point. So it's the where we are scanning in general, okay, the high level. So what is software composition analysis? It's a solution, okay? It might be the enterprise solution, it might be a free solution, it doesn't matter for now, but it actually scans open source components for known risks or known CVEs. It also scans for the license issues. And as we saw, we should integrate it in different places in our CI/CD process. Once we do pre-build or pre-compile process and the build process on the deploy point. So it should be integrated as part of our CI/CD. Vendors, you can choose your best or your favorite. It's a lot of, it's actually the open source. It's the OWASP dependency checker. It's a free tool to scan your software, your third-party components. It's also the white source, the JFrog, XRAY, the SNEAK, and others. Okay, so you can just see based on your needs and your your integrations. For example, if you have Artifactory, it's obviously that you will use XRAY, but if not, so you can maybe use white source and such. So you will choose any tool you want. Here's just an example. And so actually we have the package, we have the version, and we have severity critical on it. We have description of the issue, and we can see it, but we also have the mitigation plan. So just now fixed version for this package, for Echo Power package. So what can we do? It's a mitigation plan. So what we just need to upgrade to the version to the next major, or maybe fix it doesn't exist yet. Okay, so maybe vendor didn't provide the fix. So all the information will be on the vendor's report for the known CV. So now let's talk about unknown part. And unknown part is the infected packages where the attackers can add some malicious code to the existing or to generate the new packages and try to trick our DevOps engineers to take it. So different types or different packages issues like Typosquatting, Masquerading, we will skip it today. Dependency confusion, we'll talk about dependency confusion or name squatting, and hijacking. So let's get started. Typosquatting. As from the name, as a malicious user, I will do something very, very classical, like, okay, so I will create the new registry with new domain, but this name will be very, very similar to the existing one, or to the good one, okay, like Google. So the classic example is the Google.com instead of Google.com. Okay, and then maybe it will be the typo on the the build manager or package manager side, and it will use my registry instead of the original one. Also, I will push it as part of the Twitter Twitter messages, and maybe some other part of the on the support sides where I can answer the question and add my link to my project instead of the Google. Okay, so I will push it during the community. Okay, and I will see if someone will use it. So it's I think it's very straightforward. Just an example of the using the instead of very popular mp-lot-lib. Okay, we saw that mp-lot-lib was used. Okay, and used, actually we saw usages. Okay, so this package is not remote code execution or backdoors, but it used for crypto mining. It's also the problem, the huge problem. And what can we do? We can just need to be sure that we are using the correct name, correct project name. We also can, like many companies, they just can buy the all typo names, okay, of their primary domain, like Google, and now called all the Google and Googly and some other domains. And once someone tried to access by mistake the google.com, it will automatically redirect you to the original, to the right one. So there's the option. How can we provide the protection against the typosquatting? But in this case, as I said, attacker will create their own project, okay, this malicious and provide the malicious package. So the next type is the masquerading. So the masquerading is very similar to typo, but also the more dangerous. Why? Because I am to create this similar project. Again, I should change the name for sure, because I can't create the same name, but I will copy all the metadata and all the links, like link to repository, etc. And it's very hard to just to look at this project and say it's original or not. Like, see an example. Okay, here I will not ask you to find the differences, but I will point out those differences. But in general, it's very similar. Yes. So as you can see, the same metadata, the same repository path. Okay. The difference here is that the name, okay, the name of it different. It's not the typo, it's some kind of the prefix or postfix added to the original names in general, like market.js instead of market. And if market is a very popular package, and you can see the number of downloads here. But let's see number of downloads on the malicious one. 10. Okay, again, it's still someone downloaded it, someone used it. So that's also the problem. They are just copy paste or just fork the existing one and create and add the malicious code on it. In general, this malicious package will do the same as the original one. So if I will run my code, it will be okay. It will be runnable, everything okay. But the attacker can add just the malicious part inside the original code and do something in addition to the original code. For example, open reverse shell. Okay, so it's not so easy to recognize masquerading, because it might be usage of marked.js or marked. Not all the DevOps engineers or developers can actually understand what is the correct one. So we need somehow we need to be distinguish between two, okay, and say, okay, so this one is the correct one, okay, and not this one. It's not so easy. Hijacking is very, very hard to abuse or to create hijacking part, but it's very, very dangerous. So what the problem here? The problem here that I'm as an attacker, the malicious user, I can take other existing projects. Okay, I will take the token or somehow to bypass the username password, whatever, but I will take control on the existing project as the original user, as an administrator, for example, and then I can change or add the new version of the existing method. Just think about it that if we are using Apache command, for example, we have Apache command, and I somehow can log in as administrator. The attacking user can bypass authentication method and log in as an administrator to the Apache project and add new version of the Apache command package. Game over. Okay, it's very, very hard to identify this attack, so it's the big problem. It's the hard to do for attacker, but it's it's a huge impact. And unfortunately, we saw attacks like hijacking with account takeover. On the NPM, for example, and most popular way actually to take the account is the leverage expired maintainers on the project. So by just to recreate the emails, so that now I will use expired emails. As an attacker, I will try to register the same email for as used by the old expired maintainers, and I will try to recover password for this email address, and then I can actually take an account and add something malicious. So please be aware and just remove expired maintainers or expired emails from your maintainers list. It's a best practice. So now we get to dependency confusion. It's the most popular attack related to supply chain. So the idea here is that build or package managers will try to find the highest version on the remote for the specific packages on the remote repository. And if, as an attacker, I can now contribute the package is the highest version, existing package is higher version, build manager will take it automatically and bring it to be part of the software. So what I need to do, I need to contribute. So I need somehow to upload the new version of the package, like you see here as an example, and I should set the highest version, okay, the high version of the existing one, in order to be sure that I'm the last one, I would say, and the highest one. As you can see here as an example, I can set the version ID, something like that. Okay, if the previous version was 2.5, so now it's 6. this a huge number. For sure, it will be the highest version for this package, at least for next day or two. So it's not so easy to recognize this type of attacks, dependency confusion, because as you know, it's how the package manager, build manager, repository manager works. So they will search for the new version of this component on the repositories. And one, I just need somehow to upload this highest version there. So it's very, very popular. And Is just the before we continue, I wanted to provide some overview of the best practices or some tools you can use as part of your process, your CI/CD process. So in general, what we need to do, we need several parts. So we first need to be sure that we don't have Typosquatting. Okay, so it's different packages for different package managers or build managers exist in order to verify that we are not using typo. We also have the dependency confusion checker. I will explain it later. So what can we do against the dependency confusion? How can we verify that we are not using the wrong package version? Okay, so if we see something abnormal like 9999 on the versions and something, the jump okay, from the version 2 to version 10, for example, so it's not a normal versioning for this package, we can say, so that's something wrong here, let's stop it, okay, or let's at least alert on it. Domain check, it's against the typo and the masquerading, and also the unusual activities on the these are statistical unusual activities on the domains. Okay, it's like repositories. Again, it's like a number of downloads. Names, okay, and the new domain, this very similar name, etc. So it's a lot of tools exist that you can use in order to protect yourself against the basics, at least. Okay, so now let's back to the dependency confusion. And as I said, the big problem here is that the artifact managers or repository managers will try to find the latest version on the remote repositories. Also in general, when we're using repository managers tools like GitLab, Artifactory, etc., we call it virtual repositories, okay, because it's also will provide us the proxy for local repositories and remote repositories. And as a DevOps engineer or developers, it's transparent for me that that I just want to bring some components. I don't really know if it will be taken from my local repository or from the remote repository. It's based on the version, etc. In here, we can control this process. We can say, okay, I only want first to find this package and this version of my local repositories, and if it's not there, only then go to the remote repositories and find there. And in this case, we call it priority resolution. So I want to set priority or search priority for the repository managers and say, okay, the first of all, you will find it on your local repository always. Okay, so it's your first priority. If not there, only then maybe you will go to find it on the remote repositories. So why I said maybe? Because for some cases I want to prevent repository managers to find on the remote repositories. Why? Because we are talking about internal package. So this package, no way it will be on the remote repository. So I don't want my repository manager will even try to find it on the remote domain. So it should be on the local always. So I will prevent find it on the remote repository. And it's also the flag that vendors provides and say, okay, so we will talk about it on the next slide. We want about the scoped, let me go there. So we are talking about scoped packages. So I can define the name, okay, or the scope of my package, and then I can exclude this name or this scope from the search from the request for the remote repositories on the on my repository manager system. So I can say, okay, so this path, for example, this path it's only belong to internal repository. It's my internal packages, So I also want to use it internally only. And please do not try to search it on the remote repositories. That's the main idea here. Okay. What else? I also can use the flag and map my latest version to the specific version on the local repository. So why? Again, it's a very good practice against the dependency confusion, because I can say if I'm not using a specific tag for the version, for example, it's not best practice, but yeah, so maybe I'm using latest tag, or I'm not providing the tag and it's going to be automatically latest. We'll go into resolution for the latest version. In this case, I want to say, okay, even we have the highest version on the remote repository, and my latest version is this one specific on the local repository. And then my repository manager will try, first of all, to see if I have this flag on, enabled, and then I will say, okay, so you wanted latest, and the latest means this specific version on the local repository. Okay, so it's a good practice, but just to be aware that it might provide a lot of noise, because developers will see the same version all the time. They're using latest, but they will see the same version. So it's a big question how they will act in this situation. Okay, so as I said, one more tip for the build manager layer. So as I said, so we can skip a version tag. Okay, we can use latest, or we can skip it, like you can see here. So we just asked for LTS Alpine, and by default it will be the latest one. Okay, the latest version. So it's not the best practice. As I said, it produced unpredictable image in this case to be part of my production. So I want to avoid it. And also I want to avoid dependency confusion attack. Then someone can actually upload the highest version of Alpine, of LTS Alpine, this malicious code. So I want to use exact specific version of the LTS Alpine. So how can I do that? So the best practice is to provide the hashtag. The hashtag looks like this, so the SHA-2 and the hash. Okay, in this case, my build manager and my repository manager will bring the specific package, the specific version to my project. It's no way that someone will change it somehow because I'm using the hash, or it will bring the different version. Okay, so I'm asking for specific package. Okay, so it's a very good. It's a best practice actually. Okay, so we discussed the scoped packages. Now the last touch, as I said, we lean on the trust between us, between the customers and the contributors, open source packages contributors. But we want to build some trusted networking, some maybe peer-to-peer networking, and then as the contributor, I can place or I can upload my package to this network. This package will be reviewed and scanned by different tools by some solid authorities. I don't know what company will take the part of these authorities, or maybe Oracle, maybe Red Hat, whatever. And so they will be responsible to scan and verify and sign this new uploaded package. And then as a user or as a DevOps engineer, I can just need to configure that I'm going to use this networking as my remote repository or local repository or virtual repository. And then I will be pretty sure that it will be the good package. So it's no way that someone will masquerading or typosquatting there. So it's a good, it's a very protected networking because this is a very big trust. Okay, so and one of the projects in this area is the Persia. I also suggest you to read about it or maybe to start use it. It's just started, okay, but it's very interesting. So if it will be we're pushing it this project, and the idea is it's a very good idea, okay, and a very big potential from the security point of view, also from the performance point of view. So it's I think it's a good idea. So I suggest you to read about it. And that's it. Thank you very much. I think and I hope it was useful. You can contact me by LinkedIn, send me messages or questions, and have a good day. Thank you.